Good morning, ladies and gents. So this is our first lesson online for 2021. We hope we're not going to have too many. Guys, what we're going to do today is stuff that we did last year. We might add a little bit to it, but not much more. We're basically going to learn how to find the lowest common multiple and highest common factor and a bunch of other things. And the main thing here that we're working with is prime factor. Okay? What is prime factors? Okay? Let's think about a number, let's say, 72. 72. Now let's get 144. Okay, 144. Now 144, we can think about what are the factors of 144. A factor is the number that you can divide this number by. So for example, I can divide by 2, right? If I divide by 2, it ends up with 4. So I know I can divide by 2. I will get 70 something. What will I get? 72, right? Is that right? 72? Yeah, 72. So if I can divide it by a number and I'll get still a whole number, an integer, that 2 means that 2 is a factor. I can also divide it by 3. How do I know I can divide by 3? I don't know if you learned that trick, but if I'm adding these digits, 4 plus 4 plus 1, it's going to give us 9, which means divide by 3. That means I can divide by 3 as well. So 2, 3, and a bunch of others will be factors of 144. But now I'm looking to find out what the prime factors of 144. I'm really trying to write down 144 as a multiplication of its prime factors. What is a prime? What is a prime number? Prime number, okay, for example, 2, 7, and these are prime numbers. They're numbers that can only divide them, you can only divide them by themselves or by 1, okay? I can't divide 7 by 3 or by 2 or by 5. I can only divide by 7 or 1. Another prime number will be 17. Okay, you can't divide 17 by any number other by itself and 1. That's called the prime number. So if I want to find out all the prime numbers of 144, I want to write down 144 as a product, as a multiplication of a whole bunch of other numbers. How do I do this? Okay, you've done it before. Okay, what I'm going to do is start dividing it by numbers and it's easiest to find by starting by the smallest prime number. So we already saw that 2 divides 144. So we're going to divide 144 by 2, we get 72. Okay? Now what can we divide 72 by? Well, again, I can see it ends with a 2, so it's an even number. I'll divide by 2. Okay? Let me stand here. Okay? If I divide 72 by 2, I get 36. Again, I can divide by 2. Okay, what will I get now? 18. Okay, cool. Again, I can divide by 2. Okay, what do I get now? 9. Can I divide 9 by 2? No. So there's no more 2's. What can I divide 9 by? I can divide by 3. Fantastic. I get 3. Okay, is 3 a prime number? No. Okay, I can divide by 3 still. Well, I mean, 3 is a prime number, but I can divide it by itself. So I divide by 3. Eventually, I get a 1. Okay? So my aim in this process eventually is to get to 1. There comes a point where I get 1. Obviously, I can't divide 1 by anything without getting a fraction. So what I can write down, I can say that 144 is basically 2 times 2 times 2 times 2. Right? I had 4 2's. Times 3 times 3. Okay? So if I ask you in a test to write down 144 as the product. Product means the multiplication of prime factors. That's what you're going to write. Or, and what I would really want you to write is to write this in a short way. How can we write that as a shortcut? Instead of writing 2 times 2 times 2 times 2, I can write 2 to the power of 4. Instead of writing 3 times 3, I'm going to write 3 squared. Okay, so 144 is equal to 2 power 4, 3 squared. Okay, we'll pause here. Okay, the next step, we're going to use this to try and answer questions like, is 15 a factor of 48? Okay, now the easy way to do it will just be saying, okay, if 15 is a factor of 48, then if I'm going to divide 48 by 15, I should get an integer. Okay, integer, as you remember, we just spoke about it, hopefully we spoke about it yesterday, is a whole number, right? Obviously, that's not the case. You can also use a calculator. But we can do it in a kind of a funky way, which will help us later understand better highest common factor. So what I'm going to do, I'm going to write down both of these numbers as a product of, what do you call it, of prime factors. So I know that 15 is really 3 times 5, okay? 48 is, what is 48? 6 6 times 8. 6 is 2 times 3. 8 is 2. So it's 2 power 4. Right? It's 16 times 3. Yeah. You can do that just by doing the long way I've shown you. Okay? Now, if the prime factors here appear there with the same power, then it will be a prime factor. Obviously, there's no 5 here, so the answer is no. The answer is no. Okay? Let's give you another example. Okay, so we can ask, is 15 a factor of 45? And we know the answer is yes, because 45 divided by 15 is 3. But again, I can write 15 is equal to 3 times 5, where 45, if you do that where we did it before, is 9 times 5, so it's 3 squared times 5. Now you can see 3 and 5 appear here. They appear here. So yes, the answer is, it is factor. Okay? So if the prime numbers in this number appear here with, and the exponent here is at least as big as that, maybe bigger, then the answer is yes, they are common factor. They are, could be a factor. Okay? We'll pause again. Okay. So the next question we can ask is 60 a multiple of 18? Okay? What does it mean, multiple? Okay? If I multiply, so let's say I can say 40 is a multiple, I won't write it down, 40 is a multiple of 10, right? 10 times 4 is 40, so 40 is a multiple of 10. So is 60 a multiple of 18? I can try and think about what I can do. I write 18, that's 18. 18 times 2 is 36. 18 times 3 is 54. 18 times 4 is not sure, but it's more than 60. So we can answer that way and see that 60 is not a multiple of 18. Okay? But if I want to use my knowledge of factors, of prime factors, I can write, first of all, split them into their prime factors. Okay? 18 is 9 times 2, right? So it's 3 squared times 2. Okay? I'm going to show you after this, not in this video. In another video, I'll show you how to use the calculator to find the prime factors. So we'll do that later. Okay? 60 is 6 times 10. Okay? 10 is 2 times 5, so it's going to have to be 2 times 5. That's 10 times 6. What is 6? 6 is 3 times 2, so it's going to be 2 squared, right? 4 times 3, 12 times 5. Now, normally when you write down your prime factor, it's custom to write from the smallest to the biggest. So it's 2 squared times 3 times 5. Guys, the prime factors, the reason why we use them, prime factors are very important in maths. They are like your DNA of a number, okay? That's why we're learning all this, okay? Now, we're going to look here, okay? We've got 2, we've got 2 squared, okay? We've got 3 squared, but we've got only 3 here, and we don't have a 5. If you have, okay, if here in the big number, right, we're asking is 60 a multiple of 18? If in the big number, okay, we've got all those and perhaps more, then it will be a multiple. Over here, we've got the 2, that's fine. We've got even the 3, but the 3 here is squared. Here is only a 3. So 60 is not a multiple. Okay? If I, by the way, for example, if I, instead of 3, I had 3 squared. Okay? Right? So I squared the 3. That means I multiply this whole side by 3. That means I'm not working with 60. What is 60 times 3 is 180. Okay? 180 is 2 squared times 3 squared times 5. 180 is indeed a multiple of 18. Okay? You know it. You knew it before even using prime factors. 180 is simply 10 times 18. But you can see now I've got 3 squared and 3 squared, so that's fine. If I even add another 3 here, so 3 cubed, I need to time it by 3, that's going to be 540, then I can tell that 540 is also going to be a multiple of 18. But going back to my original number 60, okay, which is just 3, okay, the answer is no. Okay, 60 is not a multiple of 18. Okay, I'm going to stop here because this video is getting a bit too long. We're actually going to do the highest common factor and lowest common multiple in the next video. Right, cheerio.